All right, students, so we're here, and today we're talking about parts of a circle. All right, this is the first section in Unit 8, and we've been talking about triangles for about 1 billion days now, so it's going to be nice to talk about a different shape, and that's the circle itself. And here we got a good old triangle roasting a circle, calling it pointless. Boom, roasted. Lows. All right, that triangle got the best of that circle. All right, so let's follow along in the iBook. All right, we got some definitions. All right, the center of a circle. The center of a circle is typically labeled with a capital letter because it is a point. All right, the center of a circle is usually labeled with a capital letter. If the center is A, we would call the circle A and label it. You literally draw a circle, draw the center point, and call it A like that. All right. So that's what we call circles, usually just by the center. And then we got some famous parts of a circle that you may have heard of. All right, we got the radius of a circle. Hopefully you've heard of a radius before. And that's a line segment where one endpoint at the center of the circle is at the other endpoint of the circle. So it starts at the center and goes to the end. We'll talk more about that later. All right. And then a chord. All right. One time I had a student say, what's a chord? A chord is a line segment whose endpoints are on the circle. So the endpoints are both on the perimeter or the circumference of a circle. The radius, one endpoint center, one point's on the circumference. Chord, both endpoints are on the circumference. And then we have a very famous chord. This is the most famous chord of all the chords. It's called a diameter. And it's a chord that goes through the center of a circle. All right. So we have this in our iBook right here. This is why I have it up. But the center right there is boom, A. Chord is right there. Or excuse me, not chord. Right there. All right, notice how ED, the endpoints lie on the circumference of a circle. The diameter would be AFC because the endpoints are on the circumference of the circle and it goes through center A. And the radius is just half the diameter. You can check our answers. I'm a freaking genius. And then go ahead and copy and paste this in your iBook notes, all right? Unfortunate fact is I made this video, there's sound, but when I load it to YouTube, there is no sound, so I'm re-recording the lesson. I forgot to delete that. That's why that's already there. But either draw this picture or put it in yourself. All right? So, chord, diameter, radiuses, these are important stuff, all right? These are just the foundations of a circle so we can talk about really cool stuff in the future. So we got the definition of a circle. All right, circle starts with a C. This is how, like, the pronunciation, the phonics of circle. I think we should definitely spell circle with an S. You can't convince me otherwise. S upside down E, R, K, upside down E, L, circle. It's a round plane figure whose boundary, the circumference, consists of points equidistant from a fixed point, the center. All right, so every point on the circumference of a circle is equidistant to the center. All right, and we got some more special lines, all right? More special lines. We got a secant line. And a secant line is very similar to a chord, but it goes on forever. All right, it intersects in 2 points, while the tangent line intersects only 1 point. And we're going to draw some examples right here. Where the tangent touches the circle, that's the point of tangent C. Tangent C is a hard word for me to spell. I feel like tangent ends with a T, but then tangency, you remove that T for some reason. All right, and then let's go ahead and draw this right here, all right? We got some circle. Something I want you guys to be aware of, all right? You might try to get tricked on this later, is we'll call this AB, all right? Segment AB is a chord. It begins and ends, oops, here, let me myself a little bit more room. It begins and ends on the circumference of a circle. AB is a secant line. It keeps going. All right. So those are two different things. All right. We can call this this. All right. We'll call this CD, CD is a tangent line. It touches the circle at one point and one point only, where point C is point of tangency. All right, and then other things we can just talk about too. Is then we'll call it E, F, D. All right, E, D, that's a diameter. Oh, I don't know why, E, F, G. I don't know why I put D. Oops. EG is diameter, while FG is a radius. All right, so just parts of a circle, again, just laying the foundation for some stuff. And then we have, let's go ahead and check our understanding. All right, so let's just start with diameter. Boom, it's that one right there. Secant line, maybe we should start with that. This is kind of a cluster. Let me see if I know it's gonna hang out there no matter what. That's a diameter, chord, and point of tangency. Check answer. Let me see if I make this bigger. Again, chord begins and ends on the circumference. A secant goes through the circle at two different points. It's like a chord, but it goes on forever. A tangent line touches the circle at one point and one point only. And a diameter is a chord that goes through the center. It's the longest line segment in a circle. All right, and we have this theorem. All right. And I wish I could copy and paste it right here, but I can't. All right, let's do it like this. All right, done. Save the photos, and then I'm gonna add this photo somehow. Boom. All right. A line is tangent to a circle if and only if. So a tangent line is a tangent line if and only if it's perpendicular to the radius to the point of tangency. So looking up here, like if I made another radius, all right, didn't do a great job of drawing this, but that would actually be a right angle. All right, tangent lines are perpendicular to the radius. All right, and this is going to allow us to invoke or utilize Pythagorean theorem to go ahead and solve for some things. All right, so example 1, so we got this triangle right here. It's saying, is BC a tangent line? Well, only if that's perpendicular. All right, so we want to solve for DC right here, but let's go ahead and solve for AC. All right, the goal is to solve for DC, but we're going to solve for the whole thing first. So we're going to do 5 squared plus 8 squared equals x squared. 25 plus 64 equals x squared. Again, just using Pythagorean theorem because we have this right triangle. So x equals the square root of 89. All right, but realize, well, all we want is DC right here. That's all we want. So what's going on is AD, this length right here, realize that this is also a radius. All right, AD is a radius, AB is a radius, so this is 5. So DC is just going to be the square root of 89, the whole thing, minus 5. All right, we need a trusty calculator to actually compute this, and it's about 4.4. All right, stay tuned for more.